Okay, let's look at some specifics on how these values are calculated. So f of 0, remember, this is the value that you plug in. Whatever is in the parentheses is the value you plug in for x. So f of 0 means it's 0 squared minus 3 times 0. F of negative 3, and watch your parentheses when you do this, f of negative 3 is negative 3 squared minus 3 times negative 3. Well, this first value ends up being 0 minus 0, which is 0. First, the second value ends up being negative 3 squared, which is 9, minus 3 times a negative 3, which ends up being a plus 9, so we get 18. F of negative x, and mind your parentheses again, is parenthesis negative x squared minus 3 times negative x. Well, a negative squared is always positive, so negative x squared is positive x squared. Negative 3 times a negative x, negative times negative is positive, so we get a positive 3x. F of z plus 3, replacing every x with a z plus 3 gives me z plus 3 squared, parentheses, make sure you put that in parentheses, minus 3 times z plus 3. Now we need to work this out. Z plus 3 squared is not z squared plus 9. You don't distribute the square inside. If you have to square a binomial, you need to write it twice. Square means to write it twice, and then use the FOIL method to multiply that out. Okay, for the 3 times z plus 3, or the negative 3 times z plus 3, we're just going to simply distribute that. This first part, we need to use the FOIL method. So let's clean that up. When I FOIL out the z plus 3 times the z plus 3, I get a z squared plus 3z plus 3z plus 9. Then I have the minus 3z and the minus 9 behind that. When I start combining like terms, I have the z squared, a negative 3z and a positive 3z cancel, and the positive 9 and the negative 9 cancel. So I'm left with z squared plus 3z. I hope that's helpful. Let's look at the next one. G of t is equal to t plus 3 over t minus 5, and I need to find g of negative t. So everywhere I have a t, I'm going to replace it with a negative t. So this is negative t plus 3 over negative t minus 5. Well, since I'm not squaring those t's, it just stays as a negative t plus 3 in the numerator, negative t minus 5 in the denominator. If I were squaring those, then I'd have to square the negative as well. G of negative 4, let's replace the t with the negative 4. Oops. I didn't want to do that. Okay, replacing the t with a negative 4, I get negative 4 plus 3 over negative 4 minus 5. Combining those terms at the top, I get a negative 1. The bottom, a negative 9. Negative over negative is positive. Positive 1/9. Now let's replace every t with an m plus 4. So I have m plus 4 plus 3, and I have an m plus 4 minus 5. Since I'm not squaring or doing anything to the m plus 4s, those parentheses drop, And all I need to do is combine like terms. So in my numerator, I get an m plus 7. In my denominator, I get an m minus 1. And finally, for g of 5, let's plug in a 5 for every t. So I get a 5 plus 3, 5 minus 5, 8 over 0. And remember, you can't have division by 0, so this one is undefined. And then finally, the last example, the function is h of a equal a plus 2. So all these values inside my parentheses are my replacements for a in this case. So I keep the square root. The a gets replaced with 2, and I get the square root of 2 plus 2, which is the square root of 4, which just turns out to be 2. When I replace the a with a negative x, I get a negative x plus 2. Can't do anything else with that. When I replace the a with an m squared, excuse me, I get the square root of m squared plus 2. And I can't do anything with that. I can't take the square root of the m squared and the square root of the 2. These two guys are separated by a plus, so I cannot, just a note, I cannot do this. That is a big no-no. You cannot break up the radical, the parts under the radical, when there's addition or subtraction. Finally, last one here is h of negative 6. So under the square root, I'll replace the a with a negative 6, so I get negative 6 plus 2. We can clean that up and get a square root of negative 4. Since these functions are defined in the real number system, square root of negative 4 is actually an imaginary number, which is not a real number. All of our answers, all of our work has to be in the real number system. And since that result is not a real number, this guy is undefined. I hope this is helpful. Let me know if you have questions.